Have you ever wondered what actually happens the second you hit send on a question to an AI? It's definitely not just a simple query and response. So today, we're going to follow a single request on its journey through a real enterprise-grade AI system. We're going to unpack every check, every decision, and every transformation it goes through to get you a safe and accurate answer. Let's jump in.
So what really is going on inside that AI's brain? How does a system take your question, defend itself from attacks, figure out what you really want, and then spit out a helpful and, more importantly, a secure response? It's not magic, right? It's actually a super carefully engineered, multi-stage process, and it's all designed for trust and safety.
Okay, so our request journey has 5 key stages, and this right here is our roadmap. First, the input gets sanitized. Then, it's secured against any threats. A supervisor then decides where it needs to go. A specialist agent does the heavy lifting. And finally, the output gets scrubbed clean before it ever makes its way back to you. Let's break down that first step. Our journey starts the very instant the request arrives. Before any AI even thinks about the meaning of your words, the system's first job is just to clean up the raw input. This is the absolute foundational layer of security, and it's called normalization. Normalization is all about getting everything into one single, predictable format. Now, why is this so important? Well, it's because attackers love to hide malicious instructions using weird characters or tricky encoding. This first step neutralizes all those tactics before they can get any deeper into the system and got some real damage. And let me tell you, this cleaning process is incredibly thorough. Digging into the code, you can see it does everything from standardizing characters and stripping out invisible commands to decoding hidden text and even translating old-school internet leet speak. It'll even chop off inputs that are way too long to prevent overload attacks. You can think of it as a full-on forensic deep clean for your text. Okay, so our request is squeaky clean and standardized, but it's not in the clear just yet. Next, it has to pass through a gauntlet of security checkpoints, or what the system calls guardrails. And this isn't just one check, it's a whole multi-layered defense system. This table really shows the whole defense in depth strategy, the idea that you need multiple layers of security to be safe. Layer 1 uses simple text patterns, or regex, which are kind of like a bouncer at a club checking a list of known troublemakers. It's instant and it's free. Layer 2 uses a faster, cheaper AI to understand the actual meaning of the request, which lets it catch more subtle tricks. And Layer 3, using a tool called Nemo Rails, acts like a sophisticated security manager, handling really complex rules about conversation topics and flow.
And here's a look at the actual code. Now, this line might look like total gibberish, but it's a regex pattern with one simple job. Find anything that looks like a malicious web script and just block it on the spot. This is that lightning-fast first line of defense in action.
Layer 2 is where things get a lot smarter. A completely separate, high-speed AI model reviews the request against a really strict safety policy. It's looking for those nuanced threats that simple patterns just can't catch, like attempts to jailbreak the AI, social engineering tricks, or requests that could have some serious real-world consequences.
So, our request has been cleaned and it's passed all the security checks. Now, it arrives at the control tower, the supervisor node. This is the real brain of the operation, and its whole job is to figure out what the user actually wants and who's the best tool for the job. You know, a simple system might just look for keywords, but that is incredibly fragile. I mean, think about it. A request about the movie The Big Short might get mistakenly sent to a finance tool. Instead, an enterprise systems supervisor outputs a structured set of instructions, like a really clear, detailed work order that precisely defines the user's intent, the risk level, and the exact agent needed for the job. And this is what that work order looks like. See, the supervisor doesn't just pick an agent. It classifies the user's intent, it assesses the risk all the way from low to critical, and it even flags if a human needs to step in and improve the action. This structured, methodical approach is exactly what separates a fun AI toy from a reliable professional tool. Okay, with a clear, structured order from the supervisor, the request is now dispatched to the correct specialist. This is not a one-size-fits-all AI. We're talking about a team of experts, where each one is built for a specific purpose. And here is that team. You've got agents for searching the knowledge base, agents for handling financial data, agents for creating support tickets, and, this is crucial, a clear pathway to hand off the request to a human being when things get too risky or ambiguous.
Each agent has a very specific job description. The KB agent is an expert on company policy. The finance agent knows exactly how to handle account data safely. The support agent is plugged right into the ticketing system. This specialization makes sure that the request is handled efficiently and by the tool that has the right context and the right permissions.
The specialist agent has done its work and it's generated a response. But guess what? The journey isn't over yet. Before that response can be sent to the user, it has to pass through one final, critical stage, the output scrubber. So just imagine the finance agent generates this response. It's helpful, sure, but it contains sensitive personally identifiable information, or PII, in this case, an email address. Sending this out directly would be a data leak and a major security failure.
And this is the simple but incredibly powerful solution. The output scrubber acts as a final filter, scanning the response for patterns like emails or phone numbers, and just redacting them automatically. This is a critical failsafe that makes sure that even if an agent makes a mistake, no sensitive data ever leaves the system.
So we followed our request from the very beginning to the very end. This whole 5-stage process isn't just a clever design. It's an essential blueprint. Let's zoom out and see why this architecture is basically mandatory for any AI system used in the real world.
Building a system with all these checks and balances is definitely not a trivial task. In fact, the 5 stages we just walked through are actually part of a larger reference architecture that includes a 20-point checklist of components considered mandatory for an enterprise-ready AI.
This blueprint goes way beyond just routing requests. A true enterprise system is built on pillars of resilience. It has things like circuit breakers that prevent the whole system from failing if one little part has a problem. It has built-in processes for a human in the loop to review risky decisions. And it provides complete observability, with detailed audit trails so you know exactly what happened with every single request. And why.
And that really brings us to the ultimate question. This 5-stage journey, sanitize, secure, supervise, specialize, and scrub, is more than just a workflow, it's a blueprint for trust. It shows us a path toward building AI where every single step is deliberate and designed for safety. So, is this the key to creating AI we can finally trust with our most critical tasks? It just might be.